Hello again, everybody. Welcome to this HeatSmart webinar Wednesday. My name is Lisa Marshall. I am the HeatSmart Tompkins Program Director, and our program covers Chemung County, where I live, as well as Tompkins County, where this program started. I do this work because I have a long-standing interest in solutions to climate change. I have a science background, and I've been a community organizer and policy advocate here in New York for many years now. But most of all, I do this work because I'm a mom with 3 amazing kids, and I'm really dedicated to leaving the world for them as best as I can. So that's my motivation to come to work each day. And I'm very thankful to see all these friendly faces on this webinar. Dana's is my one of my clean heating interns or clean energy interns, and she's going to be monitoring the chat.
Hello, everyone.
Say hi. And you can ask questions in the chat, but I ask that you stay muted during my slide presentation, and then there will be time at the end for questions. I won't drag on. The title of this webinar is Getting the Most Out of Your Heat Pumps, and this is for you whether you already have a heat pump system, whether you're planning to get a heat pump system, or whether you are just wanting to learn more about heat pumps. So I am going to they'll launch our very first poll, and you can tell us why you joined this webinar today. So as I said, HeatSmart, I'm the program director of HeatSmart Tompkins. We were the first ever HeatSmart or clean heating and cooling program in New York, and possibly even in the world. We're a grassroots organization started by just a group of people sitting around the table thinking, what could we do to promote climate solutions in our local area? And they started out with a Solarize campaign. And that campaign was so successful that they decided to move on to something with even more impact and a little bit more challenging, which was to promote home energy efficiency, and in particular, heat pumps. And at HeatSmart, we like to tell you all about the comfort, the convenience, the cost savings, and the climate solutions that home energy efficiency, insulation, air sealing, and especially heat pumps can provide to you. We are a nonprofit. We don't make any money off of any sales. We're here for just education and outreach purposes only. And we like to say, let HeatSmart be your guide, because it can be a little bit difficult to navigate the process of figuring out how to replace your heating system or improve your home envelope. So as I said, we are a clean heating and cooling community. And this map is a point of great pride with me. NYSERDA is New York State's Energy Research and Development Authority. And when they heard about what HeatSmart Tompkins was doing, they thought it was such a good idea that they decided to fund our work and to provide grant money for other communities to do the same work that we are doing. And that was just a few years ago now. And as you can see by this map, as of 2021, most counties in New York are now covered by a HeatSmart program or clean heating and cooling program. And that's all because of what we pioneered here in Tompkins County. Well, why would we need such a thing as a clean heating and cooling program anyway? That is because to say it succinctly, we find ourselves in the midst of a climate crisis. We are every year putting more and more greenhouse gases in the air that trap heat in our atmosphere and are heating up the planet to a point that is endangering all human life, as well as the other critters that we love to live with here on the planet. So here in New York, we're really out in front. We passed last year a landmark climate legislation that requires us to reduce those greenhouse gas emissions quite significantly. So 40% reduction by 2030 and an 85% reduction by 2050. And when you look at this graph, you can see, well, where are those emissions coming from? Our buildings are a really big piece of that. And in fact, some of us would argue that buildings are bigger than transportation because of all the leaked methane from natural gas that isn't reflected in this chart. I would say buildings actually is the biggest source of greenhouse gases. So that's why we need to really figure out how to reduce the emissions from our buildings. Well, what's happening in our buildings? This is from Minnesota. It's not exactly the same as New York numbers, but it's pretty close. As you can see, we're using 55% of the energy we're using in our homes is for heating and air conditioning. And I need to find a different chart because really most of that is heating. There's very little energy going to air conditioning in New York State or in Minnesota either. And so we really like to focus on heating, but there's also climate solutions for water heating that we like to talk about, as well as sometimes we talk about appliances, especially cooking. There's electric solutions for all of those that are more efficient than what most of us are using now. So our recommendations to the public are to first take a look at your building envelope. That is how well insulated and sealed your home or building is. And that's because it's pretty obvious, no matter what you're using to heat your building, what kind of energy, you're going to use less of it if the building is well insulated. The second thing, and the thing we spend the most time talking about, are the miraculous solutions provided by heat pumps. There's two main kinds of heat pumps, and we're going to talk about those, and they are much, much more efficient than any other kind of heating on the market. We'll talk about why. And the third thing is domestic hot water, which in that previous chart, you might remember, represented about 15% of the home's energy use. And I've also seen numbers around 17 or 20%. So depending on your water use, probably how many teenagers you have, that might be a really big portion of your home's energy use. So we like to not forget about the water heaters. Well, what is a heat pump? I keep saying heat pumps, but you might not know what I'm talking about. Actually, you already have a heat pump in your house. That's what keeps the inside of your refrigerator cold. And it's the same technology that keeps your refrigerator cold that we use to heat and also provide air conditioning with an air source or ground source heat pump. So most heating systems are going to be burning fossil fuels, and the heat energy from that combustion is heating either the air or some water for radiators in your house. But there's heat energy actually already all around us in the air and in the ground. And so even on a cold day in winter, there's still heat energy in the air. So heat pumps work to transfer that heat energy into a space or out of a space in the summer through the process of evaporation or condensation of a coolant. When you evaporate the coolant in the refrigerant system and the heat pump system, it absorbs heat. And when you condense that coolant, it releases heat. And so that simple process, that simple physics, is what makes a heat pump work. And you can just reverse the process if you want cooling. So why heat pumps? Why are they so great? Well, as I said, they're super, super duper energy efficient because they're not creating heat, they're moving heat around. So the energy is used to just run the heat pump, but not to create the heat. They provide both heating and cooling. They dehumidify, which in our damp summers or on a day like today is a real benefit for your comfort and also the air quality in your home. They can also be used to heat hot water. And they can improve your indoor air quality as they dehumidify and filter the air. And if you're heating currently with propane, oil, or electric resistance, you will dramatically reduce your energy bills if you replace those systems with a heat pump system. They're also super duper convenient. I'm hearing every single day from people who are tired of chopping wood, tired of hauling bags of pellets around or coal, and would love to sit on the sofa with a remote control and turn on the heat or turn on the air conditioning. They just are concerned about the longevity of their ability to stay in their home if they have to keep chopping wood, et cetera. So the convenience of a heat pump should not be undersold. Here's some pictures of some of the different kinds of heat pumps. On the left, we have the air source heat pumps. Those are commonly called mini splits, and those are really convenient units because they don't rely on the existing heat distribution in your house. They have their own distribution. And so you can heat a whole home with these, but you can also stick one in where you need some extra heating or cooling, or in an outbuilding, a garage. They're very adaptable units, and they are just terrific. There's also ground source heat pumps. Sometimes people call that geothermal. And this is what I think of as the gold standard of heat pumps because they're the most efficient. They work by taking the heat out of the ground, which all year round is around 50 degrees. So that's why they're so efficient. You know, the air outside maybe will drop to -10, but even on a cold day, the ground is still around 50 degrees. So that really improves the efficiency. They're also the very, very long lasting heat pump systems. So it is expensive to put them in. It's disruptive. You have to either dig up your yard or have a well driller come in to sink a borehole into your yard. But once that's all done, you have a long lasting and super efficient system. And they can also provide the heat energy to heat your hot water. And then here on the right, we have the standalone heat pump water heater, which is the bottom part is like a traditional electric water heater, but this little gray thing on top is a heat pump that is heating that water. There's an electric coil in the bottom part that keeps that water warm once it's hot, but the heat pump is doing most of the work, and that's what makes it so efficient. A little bit more about ground source heat pumps. Here you see a forced air system on the left, and you can see this is the ground loop being put into these trenches here on the right. So for people who have a fair amount of property where a trench like that could be dug, that is a great solution. But if you don't have that much property, or if you're sitting right on top of bedrock, that's also easily done by sinking a vertical borehole into the ground. I don't have a picture of one of those right here. And here again are the air source heat pumps, or the ductless mini splits. There are actually also centrally ducted air source heat pumps, and we don't talk about those very much, but that's actually another option. But these mini splits are very popular, and that's what we most often see. And as you can see, there's an outdoor unit and there's refrigerant lines that go to and from the indoor heads. Here are pictured high wall mounted heads, which are very common, but there are also ones that are mounted on the floor that look more like a traditional radiator. And there's even some funky and interesting indoor units that look kind of like a framed picture on your wall. So there's some different options there. One thing I want to emphasize is that, you know, it's a common misconception that air source heat pumps don't work in cold climates, and that's just really not true anymore. There are terrific cold climate heat pumps that all of the installers we work with put in. And I'll tell you, I traveled to Norway 2 years ago, and Norway is much colder than it is here, and everyone there has an air source heat pump. So they really, really do work in cold temperatures if they're sized right and installed right. And again, the heat pump water heaters, these don't get enough credit. They really are terrific. And right now, there's some really good incentives to make these more affordable. There's a $700 rebate from the utilities, as well as a $300 federal tax credit. And those are available to everyone. And if you're income qualified, you can get additional grants through HeatSmart and through NYSERDA to help pay for these guys. And they won't work well for every home. They are a little taller than a conventional water heater. So if your basement is really short, it's probably not going to fit. And you don't want one in a utility closet in your living area, generally speaking, because they do take heat energy out of the air to heat up the water. So they're cooling the air around them. And they can be a bit noisy. So it's not something you want right in your living area. But for a lot of homes, these are a terrific solution. So this webinar is going to focus on getting the most out of these heat pump systems. And so we've developed a few different points for you to consider. And the first and the most important point, I would say, with either a ground source or an air source heat pump system is set it and forget it. So most of us are used to a fossil fuel system where you turn it down at night and turn it back on in the morning, or you have it turned down by a thermostat when you leave for work, and then you have it turned back higher when you come home. You do not want to do that to your heat pumps. It's not very nice. They don't like it. They don't operate well, and they're less efficient actually if you keep turning them up and down. So the best thing is to find a comfortable temperature for your heat pumps, set that temperature, and just let them do their work. We can't emphasize that enough. And it does take some getting used to for people, because we're really used to thinking that the most energy efficient thing to do is turn your heating system down and turn it back up. But, and I used to work in a school where we had heat pumps and we turned them way down at night. And we weren't saving money on our energy bills doing that. And the teachers and the kids were all freezing and miserable the whole first half of the morning as the heat pumps took time to heat up those big spaces. So please do not do that. And if you have an air source heat pump, a mini split, it's controlled by a remote control. And there's an auto mode for heating and cooling. And the heat pump installers say, do not use the auto mode. Either keep it in heating mode or in cooling mode, because otherwise, if on a sunny day in the winter, and the sun's shining maybe on your heat pump unit, it might think it's hot and turn on the air conditioning. Or on a cool summer night, it might turn on the heating, and we don't want it to do that. A last thing is you'll have, again, with the air source heat pumps, and you have a remote, say you want the air in your room to be 68 degrees. If you set it to 68 degrees, the air in your room won't be 68 degrees because it's measuring the temperature close to the unit, not the whole room. So you may have to set it at a higher temperature than you're used to get the temperature that you really want it to be. So once you find that temperature though, set it and forget it, and do not do not mess with it. Which isn't to say that if you were going away for a month and you wanted to leave your heating running, you should leave it at the temperature you want to live at. Of course, you could turn it down, just would expect it to take some time to ramp back up when you get home from Florida. Okay, so you want to optimize your fan speed and the airflow. This again is for air source heat pumps, but it's also for some kinds of ground source heat pumps have these kinds of wall units that would be the exact same principle. So this is mostly for air source, but there are so-called fan coils that work with ground source heat pumps, as well as VRF systems that basically have the exact same kind of indoor heads as an air source heat pump. So this is for all those people. So the fan speed you do want to set on auto. So you don't want to set the heating and cooling on auto, but you do want to set the fan speed on auto, at least at first, and let it work that way. Let it distribute the heat or the cooling that way. And if it's not, working the way you want it to, then you can play around with the fan speed and turn it up a bit. But it's happiest if you just set it on auto. And then for airflow, it depends whether you're heating or you're cooling. So for cooling, then as it says here, as it shows in the diagram, you want to direct the air up, and for heating generally you want to direct the air down. Okay. Very important is to clean the filters. It's very easy. Actually, we have some videos on our website that show cleaning the filters. They just pop out. It's very simple, and you can either rinse them off or vacuum them off. Your heat pumps will come with a manual that explains all of this, and your installer should show you how to do it the first time. But if you forget, you could always ask us or consult your manual. And how often you have to do that really depends on your household. So if you took my household with my messy old house full of dust and pets, I would probably need to clean those out quite frequently, at least once a month. But some of you might have much cleaner, less dusty, less hairy households, and you might not to, you might only have to clean your filters once every 3 months. Actually, I might have to clean mine even more often if truth be told, but I'm not sure how truthful I want to be about that. So it's very important to keep your filters clean. And while we're speaking of cleaning, you want to keep that outdoor unit, and this again is for air source heat pumps, free and clear of leaves and snow that could be stuck in the fins. Some people like to build a little house for their air source heat pump outdoor unit. That's not necessarily necessary, but if you live in a place that gets a lot of snow, or where the wind blows the snow and it piles up, you might want to think about doing that. You have to be careful though. You want to make sure there's plenty of airflow around the unit. So you don't want to restrict the airflow. And, you might worry about ice or snow accumulating on the coils themselves. You don't really have to worry about that because the air source heat pump does run a defrost cycle every once in a while in the winter, and it defrosts those coils quite adequately, and so you don't have to do anything about that. It does it itself. So annual servicing of your heat pumps, whether you have ground source or air source heat pumps, these are high-tech equipment, and it's really important to maintain them regularly to ensure peak performance. With a ground source heat pump, there are also some filters that you can change yourself, but you're not going to want to take your heat pump apart and get all the gook cleaned out on the inside. That's something that your installer is going to want to do, that kind of maintenance generally. And I've heard from a couple of people, this is kind of funny, the optimal time to get your heat pumps cleaned is in late June, after the cottonwood trees are done shedding all of their fluff. Apparently, cottonwood tree fluff is the bane of heat pumps. So you want to get all that stuff off your heat pumps as soon as possible. And that's particularly, again, air source heat pumps where that unit sits outside. You definitely want to get that cottonwood fluff off there. And, if you have a lot of cottonwood trees around, you might want to talk to your installer about how to keep that fluff off there. So you want to get, most of the inspection is just taking a look, testing the temperature that's coming out, cleaning out the drain lines and the pumps, opening up the door to check for any rodent nesting, clearing out the leaves that might be stuck inside, etc. One thing that we want to talk about with the maintenance is unless there's a problem and your heat pump isn't working well, you don't really want a pressure test on the refrigerant lines, because every time a pressure test is done on the refrigerant lines, a little bit of that refrigerant escapes into the atmosphere, and that stuff's not good for the atmosphere. So we want to keep our refrigerant inside the heat pump and contained until you take that heat pump out of service, at which point it is recycled carefully. All of our installer partners are very committed to providing service for the heat pump systems that they install. And if you sign a contract with them for annual maintenance, that means that they will call you and remind you to schedule annual maintenance, and that if you call them with a problem, they're going to definitely prioritize you ahead of somebody who doesn't have a contract with them. And another consideration is, say you got a ground source heat pump installed and you signed a 10-year maintenance contract with the installer as part of the package, you could, deduct that off of your federal taxes along with the price of the heat pump system. So you could really save on that maintenance contract. So some things to consider. But even if you didn't sign a contract, our installer the installer that installed your heat pumps is gonna be happy to help you maintain them, of course. So those are tips for getting the most out of your heat pumps. I'm going to go on to just talk a little bit about the benefits of heat pumps that I mentioned before. The cost savings are quite considerable, especially compared to propane, oil, and electric baseboard for heating your home with this ASHP stands for air source heat pump, and the GSHP is ground source or geothermal heat pump system. So as you can see, people can dramatically save on their bills. This probably does not include the cost of cooling. So if you're using those systems for cooling, the heat would go up, the cost would go up a bit. This is just the cost for heating as compared to other fuels. Okay, so heat pump systems currently are still more expensive than a traditional fossil fuel system to install. But because we think it's so important that people start to put in heat pumps, there are incentives available to help offset the costs. So for air source heat pumps, there's a rebate through the utility of $1,000 per 10,000 BTUs of heating load, which typically comes out to about anywhere between $2,500 and $6,000 off the cost. There's also a federal tax credit of a whopping $300. And for ground source heat pumps, there's a bigger rebate, $1,500, because they are more expensive systems. So that typically comes out to about $4,000 to $9,000 on the typical house that we see. But then whatever you pay, if you get a ground source heat pump system this year, and if you owe federal taxes, you can take a 26% tax credit off the cost of installing that system. And if you owe less taxes than that tax credit, you can amortize that over 5 years so that you can get the full tax credit. There's also grants for insulation and air sealing, and some of these grants under some circumstances can be put towards heat pumps as well. But these are for people who income qualify. And this table shows who currently income qualifies in the 2 counties that we cover for the various grant programs. So the Empower program right now is providing $10,000 grants. The Assisted Home Performance program is providing a $5,000 matching grant. So for every dollar you put in, they put in $1, up to a total of $5,000 or up to a total of a $10,000 work scope. In addition, and stackable on top of these grants, HeatSmart right now, through our partnership with Sustainable Tompkins, has additional grants that you can get for heat pump system, $2,000 for heat pump system and $300 for a heat pump water heater. And that, again, can be stacked on top of all of the incentives we've already talked about. And the Sustainable Tompkins also runs this wonderful thing called the Finger Lakes Climate Fund, where people offset their carbon use, and that money goes to grants here in our own community to help pay for insulation, air sealing, and for heat pumps. So that can be stacked on top of all these other grants. I do want to say that the HeatSmart grant funding is about to come to an end. So if you think are income qualified and you're thinking about moving forward, you might want to move forward sooner rather than later to take advantage of that HeatSmart grant.
Can you do it?
Okay, I won't go into details about this, but I am so excited about this. New York State is conducting a heat pump demonstration pilot study for low to moderate income households, where they are providing very deeply discounted heat pump systems for approximately 500 households across New York State. And this is so that the state can learn what the barriers are to heat pump adoption, what type of housing people have, what the actual carbon emission savings will be for these people with heat pumps, so that we can make better policy to help more people get heat pumps. To qualify for the study, you have to be in one of those income categories on the previous slide. You have to have a heating system that is older than 5 years old. Your house has to be not on natural gas. That's exempt from the study. And the insulation your house's building envelope has to be adequate to support a heat pump system for heating, or else be able to be made efficient enough for that through the grant monies that are also provided for that. So if you're interested in the heat pump demonstration study and you think you may qualify, definitely get in touch with HeatSmart ASAP. This launched in December and there's only $5 million, and once it's gone, it's gone. So at the end of all of those incentives, you still might find that the heating system that you want is more than the cash that you have on hand, and you might want to borrow. New York State offers loans through the Green Jobs Green New York program, and the interest rate depends on your income. Alternatives Federal Credit Union offers energy efficiency loans, and I think all of our installers also offer financing through EnerBank. So there are several options for financing if that's a better option for you. I want to just talk briefly about our installer partners. We have 3 of them. When it says partnered with, that's for the heat pump study that I mentioned earlier. That we have Daily Geothermal and NP Environmental. They are heat pump specialists. They're small family-owned companies with about 20 employees each. And they specialize mostly in heat pumps, air source heat pumps, ground source heat pumps, and heat pump water heaters. And so for the heat pump study, they're required to partner with an installation partner. So that's what that's about. And then our third partner is Halco Energy, and they do it all. They do heat pumps of every kind. They do plumbing, they do solar panels, they do home performance, energy efficiency upgrades, basement waterproofing, et cetera, et cetera. And so for the heat pump study, they don't need to partner with anyone because they're a one-stop shop. So that's it for my presentation. If you're interested in finding out more and getting a free assessment from one of our partners, we ask that you go to our website or give me a call and enroll with HeatSmart. That enrolling means you just fill out a short form with a little bit of information. It's very quick and easy. And you select a contractor to come to your home and give you a free assessment, which is no obligation. Oh, I should also just say about our contractor partners. Let's go back to them for a second. I guess I can't go back to them. It's not letting me. There we go. Is that they go through a very intensive vetting and interview process to be part of the HeatSmart program. So we ask them questions about their equipment, their experience, their customer service, their insurance that they carry, the way that they treat their employees, their the design principles that they use for heat pumps, and how well they want to work and collaborate with us. And if they make it through all of that, then they can be a HeatSmart partner. So we ask a lot of them, and they provide a lot for you, and that's why we recommend these 3 companies. So all right, back to the thing. So if any of this was interesting to you and you live in Tompkins or Chemung County, please get in touch with us at heatsmarttompkins.org, or you can give me a call at 607-500-HEAT. If you are outside of Tompkins County, you can find or Chemung County, you can find the program closest to you by going to getheatsmart.org. So I'm going to stop here. You're probably all very tired of hearing from me, and open it up to questions.